right, let's talk through this. So this is not anything new or anything recent, but it is stuff we've done before frequently. So we want to see if we can find a pair of number that adds to be 1 and multiplies to be negative 20. Yeah, what this is trying to figure out those kind of pairs that we would use in our x, where it multiplies to be the negative 20, adds to be the positive 1, and it would take a positive 5 and a negative 4. We've used this tool before. So look at the next one. If we want a pair that adds to be 11 and multiplies to be 18. What pair of numbers multiplies to be 18 and adds to be 11? 2 and 9. So what we're doing is what? What is this the first step that we used to use this for? When did we also use this tool? Factoring. Today we're going to review factoring because it is an incredibly important part of the next chapter. I'm not even kidding when we'll have at least one problem where we have to factor 4 times in it.
Oh, God.
Factoring is a huge part of the next chapter. Just saying. So I did make a note packet for us because I know end of the year we're feeling a little blah. That's the technical term. Blah. And it is a big chapter because this gets us all the way through the end of the year. And some of the problems, especially when we get later on, are not super complicated to write down, but if we have one little mistake, it makes things go wonky. So I did put together a notes packet for us. I did not print tons of extras because they are chonky.
They are chunky.
But remember, we have 24 school days left. This gets us through that. The only thing other than this packet we review for final. That'll be it.
Wait, is this one of the ones that we saw on the SAT reviews?
Entirely probable. But problems like this, like page 8 and 9, trying to write those down while I'm talking. Ew.
Yes.
So this is everything we're going to do, everything we're going to learn for the rest of the year. This is it. Last bit. My little binder for this chapter says Module 9 and final spread. So this is the end. Dun dun dun. The chapter test will be on April 25th, or no, May 14th. Well, a skills check April 25th. Yeah, and it's a week before the last day of school. The skills check, yes. It'll just be over some simple things. So this is a really important bit to be able to do this factoring. So I want us to remember how to do this. On the page 2, first page once you open it, we have a factoring review. That's what we're going to do today. We are going to review how to factor. I'm not even kidding when I say this is super important to this chapter. If you cannot factor, there is not a chance that this chapter is going to go well. This is a critical piece of what we're doing. So I know we've done factoring before, but if it's not something we're super comfortable with, lock in because otherwise this next chapter is going to be darn near impossible. Okay, so we'll go through these 4 on this page slowly. The most common way that I show factoring is when we're using our X in our box thing, this guy here. That X frame that we just used in the bell work and the box. This is not the only way to factor. We did it back in polynomials When we would factor by grouping, totally works as well. There's several different shortcut methods. There's several different options, bottoms up, split the middle, like that don't require these specific tools. So if you genuinely loathe the box and you would be desperate for any other option, check out YouTube. There are so many options when it comes to factoring. So if this does not work for you, or factoring by grouping does not work for you, find something that does. It's that important. You gotta be able to factor. So I'm gonna walk us through the first one pretty slowly and then we'll do the other ones together. We're thinking through with our quadratics over here as they're related to our standard form. That was our ax squared plus bx plus c. This was kind of the standard form of quadratics. No parentheses, nothing wild, nothing crazy. When we're looking at our factoring stuff, we generally put the a times c at the top and the b goes at the bottom. So what I mean by that is we're going to play match them up with these numbers. The a is the number in front of the x squared. The b is the number with the just x. And the c, there we go, is the number added on the end. So in this case, what is the value of our a? 1. And what is our c? 8. So 1 times 8 means we're looking at an 8 in this x frame. And b goes on the bottom. What's our b? -6. So the two pieces we're looking for to figure out where our factors are going to be, we find our pair of numbers that multiplies to be 8 and adds to be -6. What do we know that can multiply to be 8 and adds to be -6? -2 and -4. A good way to kind of think about it is if the top number is positive, these two pieces are going to have the same sign. So they're either both going to be positive or they're both going to be negative. If the top number is negative, one of these will be negative. So if it's a positive up here, we're looking for these two that add to be this. If it's a negative up here, these two will subtract to be this bottom number. So we're going to have our -4 and our -2. So the pieces that go in the box, this guy, the first term, goes in the top left box. That's our 1x squared or just x squared. The 8, our c, this guy also goes in the box. That's this guy down here. This guy does not go in the box. This guy does not go in the box. Please stop putting them in the box. Not saying y'all specifically, but in general, it happens frequently. These two pieces over here are the only things that are coming out of this x frame. The 8 and the 6 are tools for us to use. The -4 and the -2 are the pieces we're looking for. And they get whatever this middle letter is. So sometimes if we have a problem that has A's instead of B's or whatever, or A's or B's instead of X's, it gets whatever that middle term is. So even if we had a squared minus 6a plus 8, we could do the same thing. It would just get that middle term. That's why I say it that way instead of the x frame gets the x. So that's how we fill in this tool here. This is a tool for us to use. Again, this is not law that you have to use the box. It is a tool. It's just a tool that we're fairly familiar with. Because our last thing we need to do, because we're very nearly done with it, is we need to pull our factors in columns and rows. So what I mean by that is we're going to find our greatest common factor, our GCF. What is shared? What's shared between x squared and -4x? And x. What is shared between -2x and 8? The -2. Good. What is shared between x squared and -2x? An x. And what is shared between -4x and 8? Jose, I'm with you on the negative. But what number?
4.
4.
That's what he said.
Oh, I heard 1. I would have sworn you said -1. It is 4. It is 4. Sorry, I heard 1. I'm old, so we're just gonna go with that. My husband turns 40 this year, so just saying, we're old.
Not even basically revealing your husband's age. That's crazy.
I turn 40 next year. I don't care. Like I will share. I am not ashamed. I have pulled out my senior picture. Y'all have seen my photo on the wall over there. Just saying.
I have.
I was like, y'all can figure it out. I graduated in 2004. Just saying.
It's really, I love your picture.
It's very 2004.
It's still.
Oh my gosh, it was so 2004. But that's okay. So when we're writing this in our factored form, these guys on the outside are the pieces we are looking for here. Our x minus 2 and our x minus 4. So this is our factored form of this equation. So that's doing it the long way. There is one shortcut in here that I will tell you. I'm also going to give you its caveat. This only works when our a is 1. Only. Okay? So if and only if a is 1. What numbers did we get in our x frame? The -4 and the -2. -4, -2. You don't necessarily have to use the box. It's always, if your a is 1, going to be x and these two numbers. So x minus 4, x minus 2. So when your a is 1, you don't necessarily have to use the box. If your a is anything other than 1, you still need it. So this only works when a is 1, but it does give you an option for a shortcut. If you want to continue to do the box absolutely every single time, that is 100% okay. If you factor by grouping every single time, 100% okay. Shoot, if you quadratic formula it 100% of the time, it'll totally work. It's aggressive, but you can do it.
Be aggressive. Be aggressive.
Thank you. Grab one of these. Okay, the next chapter. Okay, so when we have an a of 1, you can absolutely skip doing the box part. You do not have to, but it's an option for us. And when we get to some of our problems that have a gabillion factorings in them, it might be an option that's helpful. So let's look at the next one and try that.
How many is gazillion?
Flip through the packet.
I'm scared.
Just gonna say, I'm barely exaggerating. I'm not kidding when I say factoring is going to be an important piece of this. And then I'm like, oh yeah, sure, whatever. Come back to me in a week. Promise. Promise I'm not kidding. All right, so let's look at this one. Again, we're looking at our ax squared plus bx plus c. Sometimes this piece is helpful to write that bit up there. If it helps you, write it. If it doesn't help you, don't write it. No matter what, we're going to need to use our X-frame tool. It really does help. It's on the very first page, just on the very back of the cover. That's when we're taking our A times C at the top, B goes at the bottom. So what is our A times C? What's going to go up here?
16.
16, because we have our 1 that's here and our 16 that's here. So we have a 16 in the top. What goes in the bottom? 8. So we're looking for a pair of numbers that multiplies to be the top and adds to be the bottom.
That's all we're doing. Just factoring like that.
Yeah.
4.
4 and 4. So if you want to use the box, absolutely valid. I'm going to write it in the factored form first to show you how we can do this, and then I'll do the box so we can see that it did work. So taking the shortcut method, since we have an A of 1, this is shortcut. We're going to have our X plus, I'm going to get 2 different colors of pink so we can do it. So I'll do this light pink. So this 4 And we're going to have x plus this 4. Shortcut mode. I could write it like that. If I go through the box, I should get exactly the same answer. If I put in my a, that x squared, and my c, the 16, and we put our 4x and 4x. When we pull those factors in columns and rows, we can see it is going to have an x here. It's going to pull out a 4 here. It's going to pull an x here. It's going to pull a 4 here. So we get exactly to this thing. So you don't have to do the box in the middle as long as your a is 1. Shortcut option. There is one other thing I want us to see on this guy down here. What is another way we could write this? Because I have x plus 4 times x plus 4.
X plus 4 squared.
X plus 4 squared. So these two pieces here mean the exact same thing. So both of those would count as factored form. You don't have to write both, but we'll need to be able to recognize that when it says x plus 4 squared, it means x plus 4 times x plus 4, not x squared plus 16. We cannot distribute powers in. That's not how that works. So x plus 4 times x plus 4 is the same thing as x plus 4 squared. Okay? This is also when I point out many of the factoring mistakes that I've seen over the last 4 months.
What?
This is also I'm pointing out factoring mistakes that I see all the time. Trying to prevent us from making those mistakes. All right, let's do another one. So this one isn't a trinomial, so it looks a little different. We've got a binomial. So number 3 here, we've got x squared minus 4. The heck can we do here?
B 0.
100%. We can do the exact same thing because we remember that it's a that's in front of our x squared, b in front of our x plus c. So what we have here is a c and an ax squared. There we go. Is there any weird overlappy thing? Yay, I don't think it is. So it's just that we don't have a b here. Our b is 0. So our a times c, our 1 times negative 4, is negative 4. And our b is 0. So what pair of numbers do we know that will multiply to make negative 4 and add to make 0?
Negative 2 and positive 2.
Negative 2 and positive 2. So we could go straight into our factored form here where we have our x with our negative 2 and our x with our, sorry, changing it to a slightly different shade of pink so it looks at least a little bit different, positive 2, this guy. Is this pattern vaguely familiar? We have x plus 2, x minus 2.
Difference of squares.
It's a difference of squares. So on this one, we don't even technically need the x frame. We can do this using the difference of squares pattern. If we remember that, great. If we don't, we now have the shortcut where all we need is a little x frame. We love that. So you can do this one with an even shorter shortcut if we remember the pattern. Otherwise, you've got this, and this is not too bad as far as shortcuts go. We've seen that. Okay, so you don't have to do the box part. If you want to do the box part on this one, totally valid. Still works 100%, totally fine. Just trying to get it so we save a little bit of space, because I know sometimes space is at a premium. So remember, the shortcut only works when we have an a value of 1. So on the very last one, we cannot use the shortcut. So on the last one for today, not kidding, last one for today, we have to do this one full out. No shortcut available. When we have an a value that is not 1, like this, 6, we cannot use the shortcut. We have to do the full kit and caboodle, whole x and box, or factoring by grouping, or whatever our method is, but you cannot take a shortcut on this one. If you do, I guarantee your factors are going to be wrong. So let's set this one up the same way we did at the start, the very first one. So we're going to use our x in our box. What's going to go at the top up here?
6x squared.
-12. We're taking the numbers.
Wait, looking at the wrong
I
thing.
was going to say, I think you're looking at the wrong place. Yeah, this is when we're going to take our a times c. So a times c goes at the top, our a being the 6, our c being the -2. So we get -12 at the top. Our b is over here in the middle. So what's our b? 1. So we're looking for a pair of numbers that multiplies to make -12, adds to make 1.
4 and -3.
4 and -3. So spotting that pair of numbers is a huge part. If that's a place where you get stuck, make a list to the side of things that multiply to make the top. So if I'm looking at 12 here, I could look at 1 and 12. I could look at 2 and 6. I could look at 3 and 4. That gives me a smaller list of options that to figure out which ones add up to 1 than trying to just in general find things that add up to 1 that would multiply to make 12. So if you need to make a little list to shorten your options, take your product. So from here, we cannot just go straight into our factors. We have to use the box. So we're going to put in the top left box the 6x squared. This guy goes top left. The -2, that goes in the box as well. That is our bottom right piece. Those two pieces, it does matter where they go. They need to go top left, bottom right. The two pieces coming out of our X frame, it does not matter where they go in either of the two open spots. So I could put the 4 up here and the -3 on the bottom, or I could put the 4 down here and put the -3 up here. It does not matter which one it is, but they're both going to get this letter. So we're going to have our 4x and we're going to have our -3x. What are we going to get when we pull out our common factor in columns and rows? So I'm going to start with columns. You can start whichever way you want to. So looking at our 6x squared and our -3x, what do they have in common?
3x.
A 3 and an x. Bless you. So we have 3x coming out right there. What about between 4x and -2? I was like, I can't take a negative out of the +4, but I can take a 2 out. This spot right here is always going to have the same sign as this box. And we're always going to put a positive right here. We are not going to factor with a negative in the x squared. That is just not going to happen. If you have a minus in front of your x squared, take the minus sign out as a GCF. We didn't have any of those in here, but we should have. So let's look at our top row, 6x squared and 4x. What do they have in common? 2 and x. And then on our bottom row, -3x and -2. -1, good. So our factored form here for our f of x is this guy on the top, our 3x plus 2, and this guy on the side, our 2x minus 1. Notice how this really does not match what we would have gotten from the shortcut if we tried to take it. So the shortcut only works when our a value is 1. Only. But it gives us an option for that, okay? So Factoring is super duper uber important. Super duper important. Okay, so this is the very start of our very last chapter of the semester. Which means I'm going to give us our very first homework of the very last chapter of our semester together. What? So there are, I want to say, 6 homework assignments left. Just 6. 95% sure it's 6. So this has the factoring that we did today, as well as what we're going to talk about tomorrow, Monday. Never mind, not tomorrow. As well as what we're going to talk about Monday. So this is not going to be due until Tuesday. So you can absolutely do all of this first problem. You can do both problems on the back. And if you're really feeling froggy, you can go through and do a little bit of factoring on some of these other problems. But I'm going to show you how to do that on Monday. So I'm going to pass this out because then you can get all of your factoring and making all of the review ones done. And you guys have about 10 minutes until the end of the period. So if you want to work on some kind of questions, totally fine. If you want to see your chapter test from yesterday, totally fine. How that goes. The grades are in on that. 100% valid, and use nurse pet, I will get it. I fully support that, 100%. If y'all ever feel like you're gonna be ill, run. None grief given. Because I really